All right, today we're going to look at lesson 86, and it's some rules for even and odd functions. And before we look at those, I want to scroll over and look at some things that you guys already know. And we're going to be able to kind of relate this idea back to what we're talking about today. So the first thing here says the product of two even numbers. So if you multiply two even numbers, you will always get an even number. The product of two odd numbers. If you multiply two odd numbers together, you always get an odd number. So we know we're familiar with that. All right, now the sum and differences. The sum or difference of two even numbers. So if I take two even numbers, add them or subtract them, I will always get an even number. The sum or difference of two odd numbers. So if I take an odd number, add to another odd number, or subtract, I still actually get an even number. And then the last one here, the sum or difference of an even number and an odd number. So if you take an even plus or minus an odd, you will always get an odd number. Now these simple ideas with numbers look a lot like what we'll talk about with functions today. So it's not going to be, the products aren't going to be the same or even or odd, but some of the same ideas to look at. So here we go. The sum of two even functions is still even. The sum of two odd functions is still odd. The product or quotient of two even functions is an even function. Product or quotient of two odd functions is still an even function. So these are the ones that kind of sometimes get tricky. And the product or quotient of an even function and an odd function is odd. So these are the functions, not actual numbers. So we're going to use this and we're going to show that a couple of these things are true. The first thing we need to do before we do that is talk about what were even and odd functions. So actually this is an example here. Let f be an odd function and g be an even function. Show that f times g is an odd function. But first I wanted to go back and look at the definitions of an even function and odd function. So here I'm starting with an odd function. An odd function, the way that we determine if it's odd, it fits this definition. F of negative x is equal to the opposite of f of x for every x in the domain. So what that's saying is if I choose negative x, so we're going to choose negative x here, and I'm going to get a y value for that, an f of negative x value somewhere. So let's say it's right there. That's going to be the same as if I put x in, I would get the opposite of f of x, or it's going to be down here, negative f of x. So what we ended up seeing with this is, and I'm just making up a function here, but we ended up seeing that for an odd function, such as sine, or in this case negative sine, the graph is it has symmetry, it has rotation symmetry about the origin. So that's just a reminder of what it looks like. So the graphing part actually is not what we're concerned about. In this lesson, we'll actually be using this definition over here on the left. And then an even function, if I plug a negative value in for x, I will get some y value. I'm just putting it here. It might be anywhere along there. But that's the same as actually if I put an x value in, I'll get the same thing. And so let's make this into an absolute value function. If you remember, an even function is a reflection, has reflectional symmetry or line symmetry. Reflection over the y-axis. But again, the graph right now is not what is important for what we're working with. But that's a review of even functions and odd functions. So now let's try to do this proof, or this show that, really it means prove. F be an odd function and G be an even function. So now that we discussed those definitions, let's see if we can show this. So we know that F, so since F is an odd function, F of negative x will equal negative f of x. That's by definition of odd function. And since G is an even function, G of negative x will just equal G of x. So we know those two things from the beginning. Now we want to see if f times G of x is odd. So f G of x. Well, that simply means, we're going way back into algebra, that we're taking f of x times G of x. Well, this means that that's the definition. We're actually concerned about what's happening when we're plugging in negative x to see how that relates. So fg of negative x is going to be equal to f of negative x times g of negative x. But f is an odd function, so this is really, this part right here is just going to be negative f of x. And g is an even function, so g of negative x is simply going to equal g of x. Well, what we have here is negative f of x times g of x, or back to this definition, kind of just going backwards, we have negative f g of x. So what we showed, when we plugged in negative x, we got negative fg of x. Well, what's it called when you plug in a negative and you get the negative of the function? That fits the idea of an odd function. So we just showed that it's odd. So f times g is odd. And that's how you'll work through these other ones that are coming up. So to show that the sum of two even functions, f and g, is even. All right. So by definition, so we know f of negative x just equals f of x because it's even. That's the definition of even. And so this is kind of our given information. G of negative x equals g of x. We want to show that the sum of two even functions is even. So we want to show, what we're trying to prove is that f plus g of x is even. Well, even would mean, sorry, I want a negative in here. Even would be if we plug a negative in, we are going to get just f plus g of x. So we want to start with a given and get to the proof. Well, let's start with what summation, sum of two functions means. F plus g of negative x equals f of negative x plus g of negative x. That's by like the definition of a sum of functions. Well, because f is an even function, what's that going to equal? F of negative x just equals f of x. And since g is even, g of negative x just equals g of x. And so, I forgot my negative over here again, sorry about that. So we just showed f plus g of negative x equals f plus, so changing this back into one part, f plus g of x. and this is the definition of even. So f plus g of x is even. And that's what we wanted to find. And now looking at this one, show that the quotient, f over g, is an odd function if f is odd and g is even. All right, so f is odd. F is odd, so f of negative x equals negative f of x. That's our definition of odd. Again, this is our given information. And g is even, so g of negative x simply equals g of x. And we want to prove that f over g of negative x, we're trying to prove the quotient is odd, so we're trying to show that that is negative f of g of x. So what we'll do is we'll start with what is the definition of the quotient of a function. Well, that's simply f of negative x over g of negative x. And we'll put this in here. I don't know that we need to, as long as g of negative x does not equal 0. And we know f is odd. So we know that f of negative x is negative f of x. We know g is even, so g of negative x is just g of x. Well, this is a negative over a positive, so negative f of x over g of x, which this is the definition of f of g over x. And so f of g of x is odd. And it's odd because when we plugged a negative in, we got the negative of the entire function. All right, so that's the proof of a few of those different things. I have some typos here. I should not have double integrals. So this shouldn't be here, and this shouldn't be here. But this, we're going to talk about, so when we do integrals, and we've mentioned this here and there throughout, especially when we dealt with sine and cosine, looking at their graph, but let f be an even function. So we just know that it's even, so that the integral from 2 to 4 of f of x dx is 7. Evaluate negative 4 to 2. Well, since it's an even function, it's going to be the same on both sides. And I'm going to actually put it as positive for right now. So I'm just making up some function. I'm trying to make it symmetric about the y-axis. So from 2 to 4, whatever this function is, the integral is 7. So this would be a 7. So what's going to happen from negative 4 to negative 2? Well, it's going to be the same thing because it's an even function. So this is equal to 7. And this is going to help us as we evaluate integrals other times. So let's go to this next one. Again, I have this bad typing in here. So if the integral from negative 1 to 1 of e to the x squared dx equals k, then what is the value of 0 to 1? Integral of 0 to 1 of that same function. Well, e to the x squared, the fact that it has this x squared there makes us think that maybe this is an even function. So let's check what type of function it is, because if it's even, we could figure out one thing. If it's odd, maybe we could figure out something else. So let's check. So let's let f of x equal this function e to the x squared. We're going to see, well, what's f of negative x? Because that's how you figure out what type of function it is. E to the negative x squared. Well, negative x squared, it doesn't matter if it's negative in here, you're squaring it, so it'll be positive, so it's actually going to be equal to this. So it's equal to e to the x squared. So when we plugged in negative x, we got the exact same thing as the original, which means f of x is even. All right, so once again, if it's even, we might not know what e to the x squared looks like, but we know that it's going to be the same on either side of this axis. So maybe it looks something, I don't know, like a parabola. But if this whole thing is k, which it says it is, from -1 is k, what is it going to equal over here on this from 0 to 1? Well, the whole thing's k. We know this is an even function, so this is split in half. So this is going to equal half k, or, which is just k over 2. All right. Okay. F is an odd function, so that the integral from 0 to 2 is 16. What is the integral from -2 to 2? Well, it's an odd function. So odd functions are opposite. So from 0 to 2 over here, it's 16. Let's say this is 2. What's the integral going to be on the other side from 0 to 2, to -2? Well, it's under the x-axis, but it's going to be -16. So what is it from -2 to 2? Well, this is going to equal 0. And so that's even and odd functions, and then we can use those to help us figure out integrals.